One of the remarkable things about the Dempsey E. Benton water treatment plant happens before it treats a drop of water. Planned and built over more than a decade and costing $90 million, the Benton water treatment plant in Garner does more than just provide up to 20 million more gallons per day of clean water to Raleigh's pipes.
This particular plant is unique in that we're reclaiming a water resource that we stopped using back in the 80s. So we had the reservoirs in place. It gives us a use of assets that currently we're only being used for recreation.
Lake Benson was originally a mill pond from which the city ran a raw water pipe as early as 1927. In 1954, the city built a new dam, creating Lake Benson. But when the Bain plant stopped pumping in 1987, water from Lake Benson stopped filling Raleigh's pipes, which meant that starting then, all Raleigh's water came from the Falls Lake watershed to the northwest. Reusing Lake Benson and Lake Wheeler on the Swift Creek watershed to the city's south gives Raleigh not just more water, but another watershed, someplace else where those pop-up showers can do the city some good in a dry summer. It also helps keep water fresh throughout the distribution system.
This plant is on the south side of our service area. The M. Johnson plant is on the north side of our service area. So it gives us the ability to feed our system from each end.
But the new plant does more than provide Raleigh and its customers with more effective distribution and a better chance to catch a summer shower. A state-of-the-art plant that's applied for LEED certification for environmental soundness, the Benton Water Plant is also a beautiful facility, paying tribute to the importance of its work and its workers. It's been described as what you get when you build the plant you need, not just the plant somebody's willing to pay for.
That is true. When you say the plant somebody's willing to pay for, it usually means you didn't add everything that you could have added to make it the very best that you want it to be. And technology, looks, design, it was all put together very well. As far as technology, ozone with the UV, this is only the second plant in the state now to have UV. Upflow GAC filters are the first ones that Siemens has put in the North America. And they do a tremendous job as far as buffering between the final filtration and the super pulsator.
UV? Upflow GAC filters? Super pulsator? What? Well, start at the beginning. A variable speed pump brings water from Lake Benson through pipes beneath Route 50 to the plant, where the water is immediately pre-oxidized with ozone, created by these generators. Ozone breaks up organic material and leaves almost no residue, making it an especially safe disinfectant.
Pre-oxidation, it oxidizes organics and other chemicals in the water to provide improvement in taste and odor, but it also attacks microorganisms that can be harmful.
Metering the water as it moves into the plant, operators then automatically mix in ferric sulfate, which helps tiny particles in the water coagulate, forming what treatment pros call flock. The flock settles out in one of the plant's newest technologies, the super pulsator.
The super pulsator, it's probably my favorite part of the plant. It's just amazing what you can accomplish in such a small footprint as opposed to your traditional settling basins.
Older plants, like Raleigh's E.M. Johnson plant, have slow mixing tanks and long settling basins where the water is mixed and the flock settles out. The super pulsator uses no slow mixing tanks and instead of settling basins uses contact plates, providing surface area for settlement. More important, instead of letting the water sit and the solid settle downward, the pulsator works by pushing the water up through the blanket of settled material, using that settled flock blanket as a kind of filter. The results have been outstanding. Water processing is measured by removal of total organic carbon, or TOC.
And we're seeing 75+% TOC removal, which the state requires 45%, and so we're well above that.
A vacuum chamber also lifts and drops the column of water, sending out a periodic pulse that smooths that blanket and gives the pulsator its name. The flock blanket is regularly flushed, and the water leaves the pulsator through pipes at the top of the pool, where the clear water is, rather than flowing down, where the flock is. From the pulsator, the water goes through its first filtration, called GAC, for granular activated carbon. Again, the water flows slowly up rather than down through the filters, because the filters contain microorganisms that consume organic impurities in the water.
It's very similar to wastewater treatment or biological processing of wastewater treatment. The main difference is that the microbes are attached to the filter media instead of being constantly stirred.
From there, the water undergoes standard gravity filtration through anthracite, gravel, and sand, and is chlorinated before it gets its final treatment in these units, where ultraviolet light zaps any remaining organisms, rendering them harmless. As in the rest of the plant, there's room here for expansion as Raleigh's water needs increase. And of course, operators manage the whole plant by a control system that automatically gathers flow and quality data throughout the plant. Water at all points of treatment is piped to the control lab where it's constantly tested. Yet once again, the Benton plant is about more than just water.
I think it's a plant they're very proud of the way it looks. It gives it a very unique look to the water treatment plant. A lot of glass, a lot of natural light, and a lot of that had to do with part of the LEED certification as well.
Mind you, LEED certification does more than just look green. Besides chemicals, energy is a treatment plant's highest cost.
We've added in LED lighting, we use the translucent panels for a lot of natural lighting. Anything we can do to help energy-wise to save cost and be less of a carbon footprint and more green, I guess you could call it.
And finally, apart from millions of gallons of clean water every day, the cutting-edge plant also yields information about how best to plan for the future.
It's good having two water plants, and the reason so is because we have the potential to watch how this plant and new technology operates.
That is, however much the Benton plant helps, the Johnson plant, scheduled to expand to treat up to 120 million gallons per day, will always be the system's workhorse.
Since both raw water qualities at that facility and this facility are similar, it allows us to do a lot of learning, what we can see there and what we need to do here in the future.
It's great to see a project come together after 10 years and finally see it built and placed into operation.